ECellDive is about visualizing biological systems in VR. The setting of ECellDive is pretty simple. When you launch the application, you're dropped in a virtual environment that we call a dive scene. There, you can establish a connection with a remote server to do a set of actions like importing data, requesting calculations, and saving results. Once data is loaded in the dive scene, it is embodied by a 3D model. To actually visualize its content, we can dive into it, which effectively transports us to another dive scene. To our knowledge, virtual reality applications already developed for research purposes mainly emphasize visualization. Although it's one main selling point for entertainment VR, we believe it cannot be the same for professional VR. Because in a professional setting, you expect tools to help you do your work, not just something that will keep triggering wow moments. And that will certainly hold true in any metaverse in the future because of the need for integration that we discussed previously. That's why we developed ECellDive with the idea that visualization is not the goal itself. We want the application to be an integrated workspace for visualization, modeling, and simulation. Hence, the second part of the key sentence for the project. For a demonstration of simulation and modeling in ECellDive, we reproduce the Escher FBA web application. If I quote, Escher FBA is an interactive pathway visualization tool for on-the-fly flux balance analysis calculations. Credits for this work goes to Elliot Rowe and his co-authors. Please check out their paper if you're interested. Before doing a flux balance analysis, we used a group by module in ECellDive to colorize edges according to subsystems. That way it's much easier to recognize famous parts of this metabolic pathway. In yellow, it's everything related to outer and inner membrane transport. In sky blue you have the glycolysis, in green it's the pentose phosphate pathway, in lime it's reactions related to pyruvate, and in dark purple it's the citric acid cycle. With this done, we connect to the server and ask it to perform a flux balance analysis. After a few seconds, we can clearly see the fluxes as the reaction edges are scaled accordingly. We see that, as already supported by biological knowledge, significant fluxes go through the citric acid cycle and the glycolysis. So, it's nice. We simulated the fluxes, but we also said we wanted to do modeling. For this purpose, users can very easily knock out reactions of the model and see how this impacts the fluxes. Let's try knocking out the glycerol 3-phosphate dehydrogenase, which currently has an important role in the metabolism. After asking the server to recompute the FBA, the fluxes have completely changed. Now they mainly go through the pentose phosphate pathway, and it became the main source of internal production of pyruvate. Up until now in this demonstration, there was only one user working alone. But it's not very realistic of a work environment in the metaverse, right? And even if you leave the metaverse out of the picture, researchers seldom work alone, particularly in an experimental science such as biology. Therefore, we believe it's mandatory for any professional VR application to offer extensive support for real-time collaboration as well as long-term data sharing. And that's why we included this aspect in ECellDive. For real-time collaboration, several users can connect in a host-client architecture on a local area network. One user will create a session, and the others will join him. Once all users are together, anybody can import data and dive into it. That way it's possible for the users to discuss directly about the simulation results and the modeling. Regarding long-term data sharing, we're also working on the format of modification file, which can let people safely keep track of who did what to a model. This ensures safe collaboration on the long term, and even if the main author of the model is not connected to supervise a work session, he can still review what happened later on. ECellDive is a virtual reality application helping us figuring out how we can do research in systems biology in the incoming context of the metaverses. Please be aware that this project is still considered in alpha stage and expected to change. Nevertheless, the code of the project and its releases are publicly available on GitHub. Critics, feedback, or suggestions are also, of course, very welcomed. Thank you very much for watching this video. See you around for more discussions.